Okay. This is a slightly different problem than your warm-up problem, but since it's already in your notebook, we'll use this one so that you don't have to recopy another table. You're welcome. We also talked about the fact that this one's expanded off to the side. Again, if you're trying to write an explicit equation, get the table and then off to the side, write out the repeated multiplication or write out the repeated addition that's happening, and that'll help you look for patterns, since with an explicit equation, I have to get from the input to the matching output. So in this guy, for our geometric sequences, we've got this expanded out. We can kind of see the explicit equation. If I look here, I'm going to highlight some things on here. How many times do I multiply by 2? Oh. Now how many times? Now how many times? Now how many times? So the number of times I multiply by 2 matches with the term number, right? And again, without expanding that out, that would be a lot harder to see. That's the value of taking the time to write this off to the side, is it lets you see what's going on with the term number and how it connects to the pattern. And we also know that a shortcut for writing this 2 times 2 times 2 times 2 times 2, a shorter way of writing that would be what? Yeah, so I can shorten this up, and instead of saying 3 times 2 times 2 times 2 times 2 times 2, I can just say 3 times 2 to the power of 5, right? Or up here, 3, because all of them have that 3 that's multiplying as well, times 2 to the power of 4. 3 times 2 to the power of 3. 3 times 2 to the power of 2. If I shorten this up, I can see the equation here. If I take one more little step and generalize this just a little bit more, there's my explicit equation. So my explicit equation, and notice this table, we didn't use function notation for our table. So to get the explicit equation, to get the output, I'm going to do 3 times 2. And then what does the exponent match with again? Oh, so I could say multiply it however many times x is, right? So if x is 5, I multiply it 5 times. There's your explicit equation. So that gives you an example in your notebook of what a geometric sequence equation looks like. It also came up too, just to introduce you guys to some vocabulary, when we looked at the graph for an arithmetic sequence, I'm going to turn back a page so you can see that. Arithmetic sequence, we said the points all line up, right? What do we call that? That type of graph when the points line up? Linear. Oh, so somebody had asked, and it would be worth noting in here because you guys are ready to think about this. This graph for a geometric sequence also has a name, and now that you're working with the equation, the name makes a lot more sense. This is called an exponential graph, because if you look at the equation, you need an exponent to represent the pattern. Genius, exactly. So we could come back here, and below this, if you want to just make a note, you can say that this graph is called an exponential graph. You guys weren't quite ready to talk about that name on the first day that we introduced this because you hadn't worked with the equation yet. But now that you see how the equation works, you're ready to have that name make sense, which is why I'm just now telling it to you. Let's do our recursive. That way we can just kind of finish this idea out. Informally, so explicit, I'm looking across. How do I get from input to output, input to output? Recursive, I don't really care about the inputs. I really only care about the outputs. How am I getting down the table? So how am I getting down the table? Times 2, times 2, times 2, right? So to get down the table, to get whatever term I want, so to get the next term, I have to do whatever output came right before that times 2. So that is the recursive equation in informal notation. And I'm going to hold off because this isn't written in function notation. We were already kind of being informal with it. I'm going to hold off on the function notation for this because, like I said, we're going to put that in a different spot in your notebook.